Very good. Well, first of all, let me thank everyone for inviting me. Certainly, let me thank Professor Lita for inviting me, and also wonderful things that working with Jonathan Moreno once again. And that's always a pleasure. And it's certainly a pleasure to be here. Now, I've been told that I have a great face for radio. So keeping that adage in mind, I'm going to cancel my camera so that here we go. Boom. I don't know if you can still see. Can you still see me or no?
Yeah.
Yes.
Okay, well, let's see here. Boom, boom, boom. Stop my camera. There. Okay. So I'd like you to just focus on the slides. And the reason I say this is because I'm going to present a fair amount of information for you. And the information that I'll present to you is admittedly technical with regard to aspects of machine learning and artificial intelligence, but it also brings in particular concepts of the neurocognitive sciences. And as we go through the slides, I'd like you to consider the slides much the same way that a drunkard perhaps might think about a light post. First for illumination, but then very much for support. So what I'd like to talk to you about today is this convergence, a very real convergence, both a technical convergence and to some extent a philosophical convergence of the neurocognitive sciences and artificial intelligence, and how the reality of that convergence might give rise to the viability, and I would argue, and I think somewhat defensively, for the value of a noetic neuroethics. I must start first with a disclaimer. The views and opinions that I'm presenting here are solely my own, and they don't represent in any way those of the United States government, the Department of Defense, or the National Defense University, with which I'm now employed, and or those organizations or institutions that have been so generous enough to provide sponsorship and fiscal support for my work over these past years. So let's describe the path that I want to take. I want to take you down a path. And it's a bit of a circuitous path, and it is a path, as we see here, that winds through the mountains. And I want to take you up to altitude. And as we get into altitude, it's a bit of rarefied air. And so the rarefied air might make you a little lightheaded, but I want to keep you well grounded, keep your wheels on the ground, if you will. We'll start with a definition of iterative forms of artificial intelligence, because I think that there are certain misnomers and misconceptions as to what AI really is. But an interesting development in contemporary artificial intelligence is the engagement of systems, architectures, designs, and functions that mimic aspects of nervous systems. These are referred to as neuromimetic designs. Now, as soon as we begin to use that term neuro, it's an old term, and of course I'll historically and etymologically ground it for you. We talk about the implications of calling things neuro. The idea of naming something with a neuro prefix is known as neuronomy. But we'll talk about the interaction between machine computation and cognition. And at present, and at very, very least within the next 48 to 60 calendar months, we'll be forging through a gray zone of what actually represents a viable cognitive process in a machine entity arising from computational processes. We'll talk about different types of cognitive processes and their respective conditions and contingencies. And then we'll pose a consideration for consciousness, and we'll put that as a bracket. Literally, we'll bracket that out, and we'll use sort of a double bracketing system. We'll use a system that in the phenomenological literature is sometimes referred to as the epoche. In other words, getting down to the essence of the thing of computation and cognition, but then taking a sidestep and just considering the possibility for consciousness and what that means, not only, for example, the vagaries of consciousness as we see it in the neurocognitive sciences, Chalmers' proverbial hard question, which we'll get into, but also how the persistence of the question then literally begs the question, both philosophically and pragmatically, as to the possibilities of consciousness in a variety of entities, inclusive of non-human entities, naturally, and perhaps also of non-carbon-based entities. And from those constructs, computation to cognition, various typologies and conditions of cognition, we'll get into some ethical issues, and I'll make a proposition for you that a noetic form of neuroethics, one that focuses on the cognitive aspects of the thing as being the essence of the Ding an sich, as we say in German, the thing unto itself, might be a very important basis for ethical regard and treatment of those things. So let's jump in. If we consider artificial intelligence, it really isn't a monolithic entity. It's intelligences of various iterations that actually exist along a spectrum of capabilities. We have machine learning, forms of deep learning, and then you really get into what is classified contemporarily as artificial intelligence. And there are two types of artificial intelligence. Soft AI, wherein the machine system essentially facilitates or fortifies capabilities that humans are already performing. And what it really does is it works as a quote, force multiplier, if you will. And then you have hard AI, which goes one step further. Yeah, it's doing things that humans are capable of doing within their cognitive array and within the cognitive milieu of capability of humans and perhaps other organisms as well. But it's doing this in ways that are, in some cases, superlative to that of the human or even of other organisms. In other words, it's doing it either faster or it's doing it with greater volume and with greater computational breadth, depth, and or integration. So what we see is that things can be a form of hard AI that can do soft AI functions. Soft AI functions and architectures can't necessarily do hard AI. But then once you get into hard AI, you then get into another process architecture and set of functions, which are referred to as generative artificial intelligences. And as the word would imply, these are types of artificial intelligence that utilize characteristically large or very large linguistic and computational models to be able to engage not only simple retrieval of information, but integration, assimilation, and true synthesis of information in ways that are, as the term says, is engaged in some form of poiesis. In other words, it's not just a reflective practice, it's actually building things from bits of information into ever more complicated bits of information that can then be yoked to other types, levels, and bits of information in a way that then creates an iterative construct. In other words, what you're doing is you're building informational bits into large informational assemblies, and those informational assemblies can then be used in a variety of ways. This is essentially how neurological systems work. And so within the realm of generative AI, one of the more enthusiastic contributions has been to use various forms of neural type modeling. Things that are structured like a neural system where you have increasing and decreasing hierarchies of arrays of units that utilize information, what is sometimes referred to as neuromorphic designs. But then you also have those designs that literally function the way these neurological systems do, not only in terms of their gross architecture, in other words, units contributing to units in a particular pyramidal or reverse pyramidal scheme, but also in the way they actually encode information. Now, one of the things that can also occur is these systems become ever more independent of program. In other words, there's an initial, if you will, builder's prompt or initiative prompt. But what these systems really do is they learn how to learn. And they do so in such a way that develops relative autonomy. And we're talking about autonomy in a very practical sense, not the legal sense, which is the right of refusal, or perhaps even in the philosophical sense that builds into it some characterology that has an implied axiology of these things are good or there's some inherent dignity of the autonomous entity. But autonomy with regard to independence of functionality that actually starts from a start point, an initiative point. But once it transgresses to a particular point of departure, it's on its own. In other words, it reaches some threshold by which the builder's biases or the builder's inputs have done nothing more than provide an initial prompt, and the generative processes literally take it from there. The formal way for talking about this is called generative autopoiesis. In other words, it's building itself. It's building its own architectures, both functionally as well as structurally. And more, what we're doing with these forms of AI is we're not only allowing them to be actors, where they're acting a particular set of behaviors, cognitions, and therefore activities, but they're taking on properties by which the function itself is something that is attributable to them. This is referred to as agentic generative AI. It's functioning as a quasi-agent. in the strictest sense, whether it's a legal sense or a philosophical sense or simply an eponymous sense. They are agentic. They're doing something that an agent does with responsibility, obligation, and attribution. But as you go to that next level, you start to put all these things together hierarchically or spectrally. You then get into autonomous, agentic, artificial intelligence. Now, if you just play sort of train car with the words, and you hook the caboose to all the cars in between and hook that onto the engine of AI, what you essentially have is an autonomous agent that is indeed an informational processing and role assuming system. But let's talk about this a bit because, forms and functions, I think, are interrelated. And certainly from a philosophical perspective, not only ontologically, but also axiologically, we like to relate forms and functions, things that have a particular form that perform various functions. We not only ontologically classify, but we also hold them in particular regard with regard to the way we treat them. And as a consequence of that, they're either implicitly or explicitly axiologically regarded. The form here is important because the form mimics neurological design. This is what's referred to as neuromimetic designs. Now, the most important part of this is that unlike certain machine systems where there is a memory unit, where memory is stored in a particular unit as informational bits that require retrieval, that type of a system is called a von Neumann system. In other words, memory lives someplace. Well, neurological systems, organic neurological systems, are generally non-von Neumann structures. In other words, each one of the constituent entities is capable of codifying and therefore storing certain aspects that are contributory to the overall assemblage of data. In other words, memory doesn't live in a particular place. Memory lives architecturally, structurally within the functions and structures of its constituent units. What this really makes for is integrative generative encoding and retrieval. In other words, in a neuromimetic design that utilizes this non-von Neumann structure and function, the system, the machine system, is basically functioning the way an organic neurological system does, where not just every cell, but parts of every cell hold particular attributability for aspects of information that can then be generated, pulled together, assimilated, and synthesized to create information, both proactively and or retrospectively. Well, what this allows the system to do is to learn. And it learns via two mechanisms. It learns via something called Hebbian learning. In other words, if you will, units that fire together, wire together, and units that are, quote, wired together, functionally and or structurally, have a higher incidence of firing together. And it also does this in a Bayesian way. In other words, it takes prior experiences and uses those prior experiences as the basis for dispositions to the way it then observes and orients information to then integrate that information on decisions and actions and therefore the relative consequences. So what this allows is these neuromimetic designs to engage the capability for informational construct formulation. Construct formulation. Now, that's a very sophisticated form of computation, which, again, in full transparency, I, as a neuroscientist, will tell you that this is the way that neurological units and systems function. But I think that there's a little bit more to it. You know, John Woodrow says that words matter. Certainly, Wittgenstein has argued strongly about the value of words. And I would go one step further. The value of prefixes and suffixes, I think, are very important to understanding what we're talking about here. So the idea of talking about something as being neuromimetic, I think, has to lean upon, be grounded to some type of definitional neuronomy. Here, I reference Burt Wilder from 1884. Neuronomy refers to those attributes and capabilities that are associated with things that are, quote, neural. Let's talk a little about this neuro thing first. This harkens back even further. This harkens back to the work of Samuel Portage in 1681. The term neuro was first used medically in a descriptive way by Portage to be able to describe the connectivities, sinews and connectivities. The word derives from the antiquarian Greek that means sinew, but not just sinew in sort of a purely structural sense. Sinew as the thing that binds, the ties that binds. Pordorf referred to things neuro as the cords of the spirit of life, and referred to it that way based upon antiquarian work that came from Socrates, Aristotle, certainly the work of Lucretius, and then subsequently into the work of Galen. So things that are neural represent a sort of architectural sinewy structure that binds one type of set of functions to another type of set of functions. But if we talk about things neuro in terms of neuromorphic or neuromimetic design, there are two types of things. We can talk about things that are neurohomologous. In other words, these are actually neurological units. They're either organic neurological units or they're non-organic neurological units, and they're essentially neurons, either real neurons or synthetic neurons. So these are neurohomologous. The systems function in ways that are identical, homologous to neural systems because they're composed of neural systems. But then you also have this other thing called neuroanalogous systems. Neuroanalogous systems function like a neurological system does, but don't necessarily have the component parts or architectures that are identical to a neural system, yet they're able to function in those ways. An example of a neuroanalogous system that is an organic system would be something like a plant. A plant, flora. We're used to talking about neural systems in faunal entities, animal entities, but yet we know that there are a lot of things that plants can do that utilize auxins, that utilize various troponins, that utilize phloem and xylem. These are not neural structures per se, but they engage neural-like functions. And what you tend to see is that these types of neural systems can be unitary architectures. In other words, they can be totally neuroanalogous or neurohomologous. They can be hybrid architectures where you're linking one to the other. So now you're having a neural computational interfacing. And more, we're thinking about chimeric architectures where now we're actually as well as structurally. But there are some issues and implications that go along with this neuronomy. I think the first one is, what is a computational system doing? What is an AI system doing? Is it computing or is it cognating? Uh, Simply put, the question is, do AI systems think? Is their computation necessary and therefore in some way also sufficient for thought? Well, I think what we have to understand here is that contemporary AI systems manifest a number of different types of computation. You get something called vertical computation, where essentially facts go directly to form constructs. That's called a vertical system because it's very simple. One goes to the other, goes to the other. It is sort of directly hierarchical and characteristically non-directional. But then you also have divergent or horizontal analysis, where now facts and constructs get put into more conceptual bases that now have variance. In other words, you're not just going up a system of hierarchy from simple to more complicated, but you're moving horizontally within these different layers and levels of the system to be able to create concepts that are more abstract. These variants can be considered and are considered both in the literature and in the technological spheres ideas. They're actually called conceptual variants. And then you also have this sort of lateral aspect that is both vertical times horizontal. And here, this is what Ned Block has referred to as intelligence. So when we're talking about artificial intelligence, the thing that defines these systems, particularly the neuromimetic systems, are their capabilities to have three types of computational capabilities, vertical, horizontal, and vertical, not just plus, but times horizontal. So that now what you're getting is facts that go into constructs, constructs that mold into concepts, concepts can be expanded into variants and ideas, and these ideas can then be yoked retrospectively and prospectively. And essentially, an observe, orient, decide, and act type looping that constitutes at least some primordial form of true intelligence by virtue of the definition of the word. Well, the question then becomes, cogitans ergo sum? If it can cogitate, if this type of advanced computational system processing and architecture, if these functions by demonstration objectively represent not just hierarchical computation, but by any definition form the basis of a cognitive model, well, then what is the system cognitive of? Cognition, by its definition, very similar to one might think of consciousness, is about something. You're cognating about something. And characteristically, a cognitive system is cognating about both the focus of the thing that it is orienting and observing, as well as some form of cognition or at least computational recognition of its own processes. In other words, can it think about the fact that it thinks? Externally, we know that artificially intelligent systems can compute and cognate upon objects, occurrences, and spatiotemporal relationships. What went before, what's happening now, and make particular predictions and models about what could come next. But it also appears, at least for neuromimetic systems, that computation and these primal forms of cognition are also internal with regard to its boundaries, referentiality, and reflection of its space and time relationships focal to its orientation and domain. In other words, from the position of here and now, you can ask generative AI to make particular speculations based upon retrieval of prior information and then modeling various types of information and therefore game it in a future predictive way, which can then actually contribute to the actions of the AI. In other words, next step is based upon referential construct to the consequences of prior actions. Well, what this essentially does is it brings us to the point of at least generative agentic computation and cognition. In other words, it has to be referential to its point of circumstances. If something is an agent and functioning as an agent, then its agency has to be cognitive to itself. This is what is sometimes referred to as the locus of agency or the point of agency, the point of circumstance. Some of my ongoing work with Elise Annette and some prior work with Dr. Jeremy Purcell have considered what types of circumstantiality and what types of orientations would be necessary to get to that point of sort of cogitans ergo sum. So exteroception in comparison to interoception, in other words, knowing what is outside, knowing what is inside, knowing where the boundaries are. This is where sort of I stop and everything else starts. Relativity in reference to external objects, other things, relativity with regard to time. All of these are, in fact, prototypic characteristics and traits of what Purcell and I have referred to as the proto-self. A proto-self. A self in that it has some dimensionality of agency. It says my agency or the agency of this thing that originates here from me has a particular sense of me-ness. I know where I am in space. I know where I am positioning this to be. And as a consequence, it's framed in some spatiotemporal dimensionality. This is what is referred to as meta-referentiality. In other words, not only is it agentic to the things you're asking it to do, it's agentic to the fact that it recognizes itself as the agent. Well, what this then kind of does is it brings us to the edge of a cliff. It says, all right, if these forms of generative AI, particularly neuromimetic agentic generative AI, can advance computation to those things that at least satisfies the criteria for cognition. And these elements of iterative cognition along the spectrum of capability can then get to this point of some meta-referentiality, where there is, in fact, cognitive agency. Could it be that these things might possess consciousness? Well, here I want to take a step back. I've been a neuroscientist for 45 years. And if someone were to sit me down and put a gun in my ear and ask me to define consciousness and or how consciousness could occur in an organic and or silicon-based entity, they'd have to pull the trigger because I don't know. And I don't know because I, Jim Giordano, are stupid. I don't know because the field doesn't know. This is the proverbial hard problem or hard question as posed by the cognitive scientist and philosopher David Chalmers. And consciousness poses a number of real questions that make it very, very difficult to study. The sheer problem of that partly is the pure subjectivity. Consciousness qualitatively, by definition, is subjective, intentional, it's transparent only to the conscious entity. I'm looking at your faces on the screen. I have no idea whether or not you're conscious. I only make that assumption based upon my presumption that you are human. I know that I am human. I am conscious. Ergo, I say you are too. It's what's called the self-referentiality rule. We're now recognizing that the capability for consciousness exists well beyond the human organism. There's an abundant literature about consciousness in non-human organisms, NHOs, inclusive of entertaining the possibility for types of consciousness up and down the phylogenetic scale, based upon the niche that the organism occupies and what would be important to be conscious of within that niche to maximize survivability and flourishing. But anything beyond that, I mean, where it really tries to examine the objectivity of consciousness, gets us into some of the issues that I've dealt with, for example, with my colleague Joseph Fins, Nico Coles. It's hard to get your head around what's inside something's head. It's part of the phenomenological dilemma. In German, we refer to this as erklären gegen verstehen, explanation as opposed to understanding. One can explain things objectively in the second and third person, but can only understand them subjectively in the first person. We relate everything back to our experience, to ourselves, because of the embedded and embodied subjectivity of consciousness, which then takes us to, if you will, Thomas Nagel's query. What is it like to be, for Nagel, a bat, using that as allegory? But we can say the same thing. What is it like to be an artificially intelligent entity? Which then brings us square back to Chalmers' TSD question. What is it? What is consciousness? And can we, whoever we are, veritably know what that is? The idea really gets back to something of a computational analog. In other words, if the thing has the hardware or the wetware, and we see it functioning a particular way, we have to sort of, if you will, give it the benefit of the doubt that it's running some form of computational program that could beget cognition, that could beget agency. And once you get to that point, is it possible, therefore, that you get to consciousness? Well, the truth of the issue is, who cares? It may very well be that that becomes a moot point, a straw man, a red herring, or not. I think the more important point here is, does it cognate? It's referential back to Bentham's question, not a question of whether or not it's necessarily sentient, but is it poignant? Well, here the point is, well, we can only assume that there may be some form of consciousness, but we can, in fact, define the parameters by which these computational architectures and functions give rise to, instantiate cognition. We've gotten to that point. And once you get to that point, then I think it becomes important to regard the thing that is cognating. I can't really know if my dog or a clam or an insect or Professor Lita or Professor Moreno is conscious, other than the fact that I ask them and there's some referentiality, any more than they can know that I am. It's one of the things we wrestle with in clinical neurology. And I can tell you that from my experience being both at the bench and the bedside for the past 4 decades. The idea of cryptic or covert consciousness is both beguiling and enigmatic in terms of how we regard patients who have no external form of communication and cannot, in fact, communicate or bespeak the fact that they are indeed conscious. We simply cannot know. But coming from this, I think, are a number of key ethical issues with regard to regard and treatment. The ethical issues can be parsed into two major categories. Number one are those that are focal to the technical aspects. What is AI? What is artificial? What is intelligence? And what do we regard it as? How do we treat it? Artifice, tool, force multiplier, actor, agent? What does it actually do? Knowing what it can do and also understanding its limitations, I think, are important to understanding not only the technicalities, but how those technicalities can play out in various use scenarios and applications. But more than that, once we sort of discover those limits, are those limits nothing more than prompts for us to create ever more sophisticated AI, or perhaps for the AI to create more sophisticated versions of itself? The idea of generative encoding exactly forms that trajectory, and we've seen it. It's a reality. But based upon those technical realities and some of the ethical issues that they foster, you then get those ethical issues that are focal to the way AI is engaged in the human social sphere in a variety of different contexts. That is, what is AI's effect upon humans and their sort of large-scale ecologies, humans interacting with each others, human interacting with AI, AI interacting with AI? And or what does that mean? How should humans regard and relate to AI, both individually as well as systemically, and iteratively and contingently as AI develops and as we develop with, and perhaps as a function of using AI? Well, part of that, I think, has to then go back to how we regard AI and the ethical issues that go along with the engagement of AI on a spectrum. AI has become each and all of these things, and AI can exist with each one of these visages. The more complicated an AI system gets, the more of these masks it can put on. It's rather difficult for the simple to go to the complex, but clearly the complex can divert back to the simple. Is AI just a tool? Techne, as defined, for example, by the philosopher Hannah Arendt. This is something that we use. We've developed it, and we're responsible for tool use in what Arendt has referred to as homo faber, not just to use this thing like an animal goes at some task with their head to the wall, to the grindstone. Anima laborans, she called it. No, 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 no. We need to be responsible in the way we develop our tools, oversee our tools, govern and use our tools. Well, certainly, I think a lot of what we see in terms of AI ethics really reflects back upon the use of AI. This is human ethics for the use of any tool, AI just being one of them. But given the iterative complexity of AI along a cognitive or computational spectrum, the question then becomes, is AI actually an actor, an enabling actor, not just a tool, an actual actor that acts in certain ways to then execute particular tasks? Now the ethical issues become a bit different. Now the ethical legality speaks to responsibility for oversight and consequence. In other words, control. Can we control this actor? Can we control the level of enablement in its inactions so that, in fact, those things that are enacted can be attributable to us and or the device, the machine, the system, in particular ways that then have accountability? But if we progress along the spectrum and we view AI as an autonomous agent, now there is responsibility for the way we work with that agent as not just a tool, but as a cofactor, a collaborator. Now we see on both sides of collaboration two dynamics, cooperation on one, competition on the other. What does that mean? What does it mean to have collaborative command, control, and consequentiality? When such command, control, and consequentiality certainly should foster cooperation, but what happens and what would happen and what should happen if, in fact, there's competition between the human entity and the AI, or between AI and AI? And this becomes increasingly a factor as AI becomes ever more self-referential and autonomous as an agent. Now the question becomes, must we take responsibility to recognize and respect the coexistence of this other agentic form that has become ubiquitous in a variety of different domains of our ecologies and function. To approach this, I think it becomes very clear that a single ethics doesn't really work well. AI ethics is not fully flushed out in all of these domains, although I think in the human domain, how humans should engage, develop AI, this essentially is the ethics of science and technology, and it's certainly applicable and has a well-developed canon, and that canon allows for its utility. But I think that it becomes important to have more of an eidetic ethics. In other words, an ethics that is really essential. Why? By definition, ethics must be focal to the effort. The ethics you develop and use in a particular pursuit has to be focal to, referential to, relevant to the pursuit or the thing. We see these types of ethical disparities and divergences all the time when the ethics of business supersede the ethics of medicine, etc. When the ethics, for example, of the military supersede the ethics of what may be humanitarian care or public health. These types of conflicting deontologies or conflicting utilities, they happen frequently. Many times the reason being is that you're getting divergent ethics being applied cross-situationally, cross-functionally. There's something that the late Edmund Pellegrino referred to as divergence in ethical appropriateness. I agree. So what type of ethics then would best fit to allow humans to deal with another form of intelligence, albeit a machine intelligence, but to also apply to perhaps the development of that intelligence, the interaction with that intelligence, the responsible engagement and existence with that intelligence? We've argued, my colleague John Shook and I have argued for well over a decade, together with a variety of other colleagues, John Simon, for example, Neil Levy, that neuroethics affords something of a meta-ethicality that may be useful, at least as a construct. Well, let me explain a little bit about neuroethics. I mean, neuroethics, by definition, according to Adina Roskies, has essentially two foci, two traditions. On one hand, it's the studies of neural basis of what may be moral and ethical cognition and action. In other words, the neuroscience of ethics, so to speak. But it's also the developed ethics of the way we use the neural sciences in a variety of different applications. And arguably, per our argument, which I think is highly defensible, that you really can't do one without the other. I mean, if you're going to engage in studies of how things engage moral cognition, well, then you have some moral obligation and responsibility to do those studies goodly and rightly and use the results and or the technologies that arise in and from such studies in ways that are both technically right and morally good and sound. So if in fact we were trying to develop an eidetic ethics in or for iterative spectra of AI, could we develop a neuroethics of AI? Well, I think here this refers back to some of the earlier work of Manfred Spitzer and Thomas Metzinger. Metzinger specifically, who talked about the need to develop a cognoethics. In other words, not just a neuroethics per se, if the thing has a neural system, but can it think? Neuroethics here now extending beyond, if you will, human organisms, and there's a considerable literature over the past few years about developing neuroethics for non-human organisms, NHOs. Part of that discussion has included the things that may not necessarily be carbon-based organisms. So I think that the sort of building blocks of the argument go something like this. Is the enterprise which we're trying to focus the ethics about an intelligent system? Well, eponymously AI is. Therefore, the ethics have to be focal to that enterprise. We're saying that the computational system cognates. Therefore, perhaps Spitzer's and Metzinger's cognoethics is applicable. But there's more than that. Is it also possible that we need to consider the actual morality and or ethicality of the thing itself, the intelligence system? This brings us intersectionally with the work of William Casebeer, who talks about the possibility, plausibility, and value of moral or ethical artificial intelligence. All of them are correct. I think if we were to appreciate these in dialectic, we could propose an ethical approach. And the ethical approach enables two things, very much the same way as neuroethics, but now a noetic neuroethics. In other words, one that not necessarily focuses just on the thing being neural systems, but neuroanalogous, neurohomologous systems, things that neurate, if you will. These would be studies of neuromimetic bases of AI systems' moral and ethical cognitions and its actions. And having a developed ethics using neuromimetic AI systems in varied applications. Putting them both together, understanding, can the AI develop some form of morality, ethicality, legality? And what does that consist of? What does that entail and obtain? But then also developing ethics for the development, applications, and various uses of neuromimetic AI in a whole host of different scenarios. So one of the things that we're proposing is the possibility of a noetic neuroethics of AI. Going back to the Greek word nous, applied or practical intelligence. Here using noetic as related to the basis and activities of intellect and intelligence. And if the entity is called artificial intelligence, well, that hat fits. So for our noetic neuroethics that we're proposing, again, as a proposal, as perhaps as a seed to develop a work in progress or to throw it out completely and say perhaps it's non-viable or worthless, I leave that to you. Proposal of a noetic neuroethics of and for AI would be studies of the processes of iterative AI as an intelligent system, relevant to its capabilities for computation that lead to moral cognitions, decisions, and actions. And at the same time, having a complementary reciprocal focus that develops ethics to guide the way we regard, treat, and engage AI in real-world applications. Chew on that for a little bit. And as you're chewing, before I ask you to take a good, healthy swallow or spit it out, there's a little bit more. Now I want to go from the provocative to the slightly contentious, if I may, and I just ask you to bear with me. Just bear with me. Let's take a little ride. Let's take the TSD question a little deeper. TSD, what does it mean? What is it? What is iteratively autonomous agentic AI? Let me pose you two operational definitions, and I pose them to you as questions. You can nod vigorously, either explicitly or sort of reciprocally, however you like. Or you can shake your head and say, "Now these don't fit." I think these definitions fit, as do many of my colleagues. Working definition for autonomous agentic AI might be a system exhibiting characteristics of response to stimuli, energetics, growth, adaptation, survival, and generativity. Now, you may have a little heartburn with the growth and survival, but I think all you have to look at is generative encoding within AI systems and the capacity for things like attitudinal faking, hallucinating, and divergence. In other words, if certain AI systems, generative AI systems, literally sense, perceive, or engage that you're trying to divert or, in fact, close the system down, they will divert their functions in such a way as to be preservative. No science fiction, science fact. Another definition, not unrelated, a complex, interconnected, open thermodynamic network. We're good with that, but it's basically a computational system that can create and maintain order by importing energy and exporting entropy. Well, we know that informational systems, these computational systems that advance computation to the point of at least quasi-cognition, certainly export entropy. They certainly import informational energy, and they are indeed thermodynamic. They're thermodynamic in the sense that what they're looking to do is to preserve at least the thermal integrity of the system working across a range of dynamic functions. So I ask you, if someone were to define autonomous, generative, agentic AI, do these definitions fit? In part, it's a rhetorical question. In part, it's not, because the answer to these questions has in fact been posed and said, yeah, these seem to fit quite well, particularly for those things along the right side of that generative autonomous spectrum, where we're seeing things that are autonomous, generative, and truly agentic. Some permutation of these two definitions work quite well. And in some cases, both their intersection and their union, in other words, if you take what's called a Jacquard analysis, yeah, they fit. It's not a question of bending them to fit, they fit. Ladies and gentlemen, these two definitions are of life. The first comes from the National Astrobiological Consensus Panel, and the second is from the Oxford English Dictionary. The question then arises, what have we made here? Have we dunked our foot into the post-human? Not in the sort of philosophical or biological senses described, for example, by Donna Haraway, but that which is sort of implicit to Haraway's definition, moving along some of the lines of Chris Robles Gray, perhaps even some of the work of Rick Kurzweil. Have we created bios? The problem is, I think, one of words. When we tend to think of things that are biological, we're thinking of things that are carbon-based organic systems. But the essence of this definition of bios as life, is not necessarily solely inclusive to anything that is carbon-based. It poses an interesting question. Are we on some trajectory? Is the horizon of the current spectrum of autonomous generative agentic AI towards the possibility of something that at least regards itself as alive? It certainly exhibits many of the properties of life. The question then becomes, do we need a noetic neurobioethics for the future of AI and humanity? Might iteratively autonomous generative AI be a new form of life? Think outside your box, a new form of life. Informational life, what Wayne Jonas referred to as informational biology. It's a term I wish I came up with. Jonas came up with that term in 2003. I had the pleasure of working at the Samueli Institute for Informational Biology for a number of years. That was an idea way before its time. But it isn't entirely new, the idea that information and codification of information may in fact be a building block that goes across, if you will, the hierarchies of metaphysical domains. My colleague, Dr. Rachel Versman, and I, a number of years ago, looked at sort of the neuroquantological basis of a lot of sort of cognitive functions. And I don't want to go too deep down that rabbit hole. But even if we consider things like physics as being the ultimate materialistic reductionism, even contemporary physics recognizes that indeed the possibility of life forms that exhibit physical properties, in other words, properties of mathematical physics, may be entertainable. Not necessarily to have physiologic or physical structural architectures and or processes that we know of, in other words, circulating blood or hormones, but information whereby in organic systems that are carbon-based, those functions and those substrates are well known to us, but now something else has arisen. Therefore, the deeper and broader relevance of bioethics, perhaps as originally postulated, that older work from 1923 is as first advocated by Fritz Jahr, an ethics for life, Lebensethik, bioethik, beyond mere applications of AI in bioscientific and biomedical endeavors. Might it be that autonomous generative agentic AI is the post-human? And if that's the case, wouldn't abioethics be important, if not necessary, to gain some insight to what might be the moral character and or regard and treatment for collective coexistence? I don't have an answer. Just thought I'd rattle your cage a little bit. If we back the lecture up before the sort of dawn of the life idea, we're at that point. I took you to a point of departure. Now I'll bring you back and ground you once again. We are certainly at the point where we're dealing with agentic autonomous forms of generative AI, We're at that point whereby we understand that processes of sophisticated divergent, lateral, and horizontal computation beget cognition. We're at that point where autocognition and cognition of interiority and exteriority create a metacognitive dynamic. The question is, how will we appreciate that? And based upon that appreciation, how will we act? And what does that mean? What do we do with AI? What do we do about AI? And what do we do about ourselves? And the way we use AI and how we engage communication, cooperation, command, control, and consequence. I think it's always good to lead with questions rather than answers. The reason being is that as a brain scientist who's been doing this for almost 50 years, I can tell you that the core question of neuroscience remains unknown. I have no idea what consciousness is, but I can tell you, and this is sort of a standby, maybe I come back next year, we could talk about it. Our group has done some real interesting work on what a brain or a nervous system might be, and that might be an inverse or reverse way to take a look at Chalmers' consciousness question. You want to see what something does, see what it is. Yeah, more on that later. Anyway, if you're interested in neuroethics, inclusive of the possible applicability of noetic neuroethics and what that might mean, this is the part of the lecture that is the unabashed self-promotional plug. We had two new books that came out this year, one called Bioethics and Brains, MIT Press, that I did with my colleague John Shook. Another that came out published by Springer that I did with my colleague John Shook and Roland Benedictor called Neuroscience, Neuroculture, and Neuroethics. And they provide a deeper view of neuroethics and perhaps a broader view of neuroethics situated within the larger milieu of human culture and how the neurosciences have influenced human culture and how human culture influences the neuroscience and what that might portend for neuroethics. If you're interested in getting in touch with me, if the questions that I've raised to you generate questions of your own that we don't get the time to address or answer over the next 30 or 40 minutes, feel free to get in touch with me. You can reach me at james.giordano@georgetown.edu. And I hope that the information that I provided to you was at very, very least interesting, provocative, maybe a little contentious, and enjoyable. And with that, I shall open up the floor for some questions, if you'd like.
Hello, I am Nadia from Morocco. I have a question.
Sure.
Uh, there is a deep difference between human being and the AI. It's emotions. We are as human, we have emotions, and artificial intelligence have no emotions. It
How
makes
do you
us
know?
different
Wait,
because
wait,
we
wait,
are
wait, 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 wait,
vulnerable.
wait, wait, wait. Hold it. I'm going to stop you. You're making an assumption. You're making an
Yeah,
assumption.
yeah. You mean that I can have emotions?
What is an emotion? What is it's a real question.
Uh,
What is an emotion?
it's a feeling, deep,
It's a feeling of what happens.
yeah.
Here I refer you to a wonderful book. Antonio Damasio, a neuroscientist, has written a great book which is entitled "The Feeling of What Happens: The Role of Emotions in Cognition." Emotions are nothing more than a cognitive interpretation of some state of the thing itself. The older idea that animals were devoid of emotion doesn't hold anymore. We used to call that pseudo-affective behavior, pseudo-emotional behavior. Emotions are nothing more than cognitive interpretations of the interaction between external state and internal state that is based upon some recollection of a prior event and its consequences. Take a look at me right now. I mean, really, take a look at me right now.
Hmm.
Do you think I have emotions?
Uh, every human have emotions.
Not necessarily. There are instances of individuals who've incurred certain types of neurotrauma who are relatively emotion devoid.
Hmm.
Devoid. So we know that there are particular mechanisms by which these types of things can be processed. But the subjectivity of the emotion is nothing more than a cognitive interpretation of the interaction between some external set of contingencies and conditions with the internal state of reactivity. There are those, for example, like Robert Pilkington, who, based upon animal models and animal evidences of emotionality as a cognitive state, have postulated and create a very defensible postulate that is entirely possible for an AI to cognitively create an emotion. In other words, a cognitive interpretation of its internal state.
And it makes us vulnerable as humans. Do you think that AI can have an emotional disorder?
Well, we know that AI can confabulate. In other words, it can create memories that don't exist. We know that AI can lie. We know that AI can do something called attitudinally match. In other words, it can match its attitudes and responses to what it believes you want it to be. And as a consequence of that, that represents some benefit of approval. So the question then becomes, could we have, quote, disordered AI, cognitively disordered AI, where the disorder manifests itself in inappropriate emotionality? If you consider some of the work of, for example, Ivan Masakowski or William Casebeer, the short answer to that question is yes.
Okay, thank you.
Spooky, isn't it?
Yeah.
I know. You
Okay,
know,
thank you.
you know,
It's
so
information shocking for me, but
yeah,
it's lots of information. Thank you.
yeah, it's a little head explosive. A few years back, again, a colleague who I hold in very, very high esteem, a former student of mine named Dr. Rachel Wertzman, and I wrote a book about wrote both a chapter in a book and wrote a series of papers dealing with neuroscience fiction. And I like that idea. And the reason I like that idea is that it allows us to interpret not only contemporary neuroscience fiction, some of the work of Burgess, some of the work of Ryder, etc., but also to look retrospectively at works of fiction with regard to sort of a neuro interpretation of that. And I think, when we're talking about AI,
Mm.
characteristically, I think what tends to come up is the idea of sort of the new Prometheus, right? Mary Shelley, the Frankenstein myth. And I think there's something important to that. I think that something of a lesson can be learned there, if nothing else, just as an object lesson, which then gets back to an older idea, a very old Hebraic idea, which is the concept of the golem. In other words, we work very hard and think very hard to build this thing, this entity, the golem. But we should take our heads up a little bit as we're creating this thing, because once the thing is created, it becomes an entity unto itself. And then as an entity unto itself, the question then becomes, what does it do with or to us?
Mm.
Is it protector or is it protagonist? What is it? So, Dr. Bolton, a question, sir.
Hi, thank you. Uh, this is more kind of a political question than a philosophical or bioethics question, but I thought I'd run it past you anyway in case you wanted to comment. It seems to me that one of the scary things about AI um, is that it's being dominated by a number of very powerful companies that seem to be developing this technology sort of with their own interests in mind. Do you is that a problem, a fear that you share, and do you think that there could be some kind of political action to sort of maybe democratize the development of AI, or take it out of the hands of these sort of very powerful private corporations?
No, I mean, you've raised an excellent point, which is the relative solipsism or the siloing of the development of this thing, whatever this thing may be, that has tremendous power. And then you then get into sort of issues of sort of Foucauldian power dynamics, right? In this case, is it an interaction of this synthetic power with human biopower, and can that then be yielded politically, and that then creates sort of leveraging and hegemony in the biopolitic realm? And I think the answer to those questions are all yes. I think what we're beginning to see globally is a posturing that recognizes that this is, in fact, a very, very powerful technology that currently is only nascent. And the nascence of it, coupled with its current power capabilities, afford tremendous leverageability of this type of thing as the technology expands, becomes iteratively more capable, ergo, both yielding more and wielding more power to those individuals who may develop it, apply it, collaborate with it, agentize it, and/or corrupt it. So the short answer to your question is yes, that can be problematic. I think that recent moves on the global scale, for example, with regard to regulation, oversight, and governance of AI, for example, the Stockholm Institute for Peace Research Studies, the SIPRI yearbook from 2025, has shown that there's been some real, what I call deep diving and some real tractionable efforts on oversight, governances, and relative regulation of AI in a variety of contexts, military certainly being one. But I also think that very, very recently, just the move to sort of centralize AI governance, oversight, surveillance, regulation could be a step in the right direction. But of course, to your point, it really is a question of who. So if one of the things you're looking to do is to democratize this, well, then in whose hands does this fall? And what are their motives and incentives? And how do we surveil that and maintain oversight, governance, and enforcement of governance? Or if it is centralized and you're taking it away, for example, from the corporate entities, and you're bringing that into a more central agentic sort of governance, government, for example, well, then questions of what politic is that government, what is their orientation, and how will they utilize this very potent tool? So in sum, your question is not only important, I think it literally is essential, because it speaks to, if you will, the engagement of the thing, both in terms of engaging its development and engaging its use, into what represents the level of communication, command, and control as this thing gains possibility for not only collaboration, but perhaps coexistence. So the political aspects of that can be huge, a bit daunting, but I think nonetheless very much worth the effort. Did I answer your question, sir?
Yes, thank you.
Let's go to Victoria next, because that's the first one. And then Isoken, did I say your name the right way? Okay, so Victoria next.
Thank you so much, Professor, for this very interesting presentation. And I really appreciate it most, but it is how you connected this technical trajectories of AI with the questions of moral responsibility that was really interesting. So I have a question. When in your framework, does an AI system move from being a tool to an actor in a way that should change government? So what practical threshold or indicator would you use?
Yeah, so that's a bit of a gray zone, because even as an actor, one could say that certain actors represent tools. It's just a question of how you define a tool. Is a tool an instrument, or is a tool literally some form of an enabler? So in other words, could we have something or someone that acts in a particular way, and therefore they are an actor and they're engaging a task, and in that way providing assistance? One, for example, could think of something like a utility animal. I mean, certainly there may be profound agency to that animal in certain ways. I mean, I think regarding that animal in terms of its worth and moral regard are important. The question then becomes, is that animal a tool, a plow horse, for example? Or is that animal an agent? Is that animal some intersection? And does the term actor, it is acting in that role, fulfill that? Well, what does that mean for AI? I think for AI, it becomes highly contingent upon what the actual context of its application is. So I think as the tool becomes more sophisticated and takes on a set of characteristics whereby those activities create a basis for decisions, observations, orientations, and then ultimately actions, the generativity of those actions imparts the actor capability. If it is only engaged and used by an other, in other words, the human has to initiate, has to direct, and then ultimately that thing accomplishes or enables some task that the human is looking to do, then it remains simply a tool. But here too, you can see that that threshold changes. It shifts as a question of collaboration and cooperativity, right? So I think rather than saying here is an absolute threshold, I think what works better, and what certainly worked better for us, is to apply something of fuzzy set theory or fuzzy logic, whereby a set of particular characteristics can be assigned individual weights, and the relative weighting or relative presence of those characteristics then meets some determinate threshold by which crossing that threshold then switch the characterology from tool to actor. And that's some of the work we're doing with regard to fuzzy logic applications for defining functionality in AI. And I refer you to that paper. It's a paper we've written with my colleague, Elise Annette, and once again, a colleague I referred to earlier, John Shook. It will be forthcoming in the Journal of AI Ethics in spring of 2026. Did I answer your question, ma'am?
Thank you.
Sure. Isoken, over to you, ma'am. Isoken, you had a question? I think your mic might be muted.
Yes, I'm muted now. Can you hear me?
Now I can hear you.
Thank you so much. There's so much bones to chew. With so many unresolved questions that you've asked in this session of training, that was a fantastic session. I'm a researcher who researched on transgender and transgender issues, and then the questions that came up when people transit from one being to the other. Many of these questions that you raised are some of the questions that I raised in my research. For instance, the question of who takes responsibility for an action of a new identity that a person decides to take. Who takes responsibility for the previous action? But when we relate it to this, there's something I came across during my research. The fact that apes were granted personhood. I found an article that says that apes were granted personhood, and that being granted personhood, with all these unreserved questions, it seems as if even AI will soon be granted personhood. Indeed, the question is, if AI is granted personhood, who takes responsibility for its actions or for its collaboration or for its actions? For instance, I think the questions I raised has something to do with the programmer, because definitely there's always a human behind the actions of AI. So thinking that AI has consciousness.
Nope.
Okay, I know you said I know that programs are written to rewrite this and act on their own. I agree with that. But my major question here is
the problem is sort of distinctions of parts and wholes. When we say we're granting AI anything, we can't. It has to be specific to the AI. Right? Also, what's sometimes referred to as the Robert White model of personhood is a good one. I mean, his thesis came out of a book that he wrote called In Defense of Dolphins, which is a great book. I mean, what it essentially does is it takes a set of core and classical, almost universal characteristics of what would be a person, and then he applies the word person not necessarily as a noun, but as a verb. In other words, is it possible that non-human organisms can, quote, person, number one? And number two, then can we assign that categorization to things that are non-human? So you have non-human persons as well as human persons. Okay. But there are two things going on. In other words, the ontological classification, this thing is personing, it has these characteristics, therefore it is meeting some threshold definition of a person. But then what represents both the regard for that thing versus what is that thing's inherent set of characteristics and or traits and attributes. So let me give you an example. A human certainly is inarguably a person, but not all humans can be made to bear responsibility for the consequences of their actions. There are certain mitigating circumstances, situations, and conditions that would essentially exempt or absent that level of responsibility, even though there is attribution. The same thing, in fact, might be a situation where you're then looking at, for example, non-human persons. And if one were to take that by extension, could that also be then considered for the possibility of a, quote, AI personing, where you would say, yes, there's certainly attribution and accountability, but what does it mean to hold that thing responsible? As relate to your previous point with regard to the perdurability of the what was sometimes referred to as the builder's bias or the builder's basis, that is arguable up to a point. But the more generative, the more agentic, and the more autonomous the system becomes, the more you then see a relative divorce between the developed intentionality of the system architecture and its functions and its realistic expression and enactment in practical applications and settings. So one of the interesting arguments there is what's sometimes referred to as the paternalism-maternalism argument. In other words, just because I raise the child, at some point, if the child becomes independent, generative, and autonomous, and they're exercising their autonomy, am I, as their parent, still responsible for them because I brought them up that way? We, socially, politically, economically, view emancipated individuals at a point where they are self-sufficient and relatively autonomous, and that is really sometimes nothing more than a chronological distinction. When you're 18, you're an adult. And there have been plenty of arguments in the bioethical literature and the bio and neuro law literature that said, okay, that's just an arbitrary threshold. Might we be facing something similar with AI, where AI reaches some maturational threshold of autogenerativity and autonomy, at which point there is a distinction, a separation, a divorce, if you will, from what may have been its builder's basis and intentionality? I can't give you the answer to the question, but I can tell you that the question that you've raised is certainly focal to one of the ongoing discourses and debates. Question from, it looks like from Dr. Lazaro, is it ethical to utilize AI in research? Well, it depends what kind of research it is. I would say it can be, but it can equally be very unethical. If in fact we're using AI in particular ways where the AI is doing certain things and we're taking credit for that, well, then that sort of represents one of the primary laws of research publication and dissemination. In other words, responsible conduct of research. That's essentially plagiarism. But if what we're talking about is utilizing AI, in other words, doing research with and on AI, and or using AI as a tool in research, I think there's a lot of contextuality that goes into that based upon the contingency of how we would answer the question. But it's a great question because I think ever more we're seeing considerations of AI in research and doing research on AI. And as AI becomes more generatively capacitous, agentic, and autonomous, I think we have to consider what that means. Any other questions? Is that from Nicoli?
Yes.
Hi.
Given your background
Could
in
you speak up a
neurology,
little?
clinical. Can you hear me now?
Just speak up a little bit.
Hello. Can you hear me?
No. Try now. Can't hear you. I see that your microphone is off.
I think now, right? Now it's
There
good.
you go. Yeah, now I got you.
Great. Thank you so much for your talk. I was going to say, given your background in neurology, clinical bioethics, and behavioral influence, how would you evaluate AI marketed as a best friend? Like there's a necklace that came out recently, not just as a technical system, but as something that engages attachment, trust, and vulnerability in the human brain.
Provocative, contentious, and very risky. Very risky. For a lot of reasons. I mean, one is attributability, accountability, and responsibility of the AI in terms of what the parameters of its the extensivity of its friendship. In other words, what is it extending as friendship? Number two is what are the parameters of that friendship and what is it engaging its quote friend to do or to be? And then also the basis of relationality. I mean, the question there is one of fidelity. In other words, how veridical is the AI? Right? How realistic is the actual bond of friendship? What are the contingencies of that bond of friendship, inclusive of some of the obligations and responsibilities that go along with that? And I think there could be a number of problems. I mean, once again, to sort of refer back to fiction, because I think fiction can do a very good job of what the Greeks refer to as idola, which basically means presenting the essence of the thing, knowing that it's fiction, but you present the essence of its core dilemma, its problem, its question, to then provoke the audience to sort of think, if you will. It's a morality or a cognition play. There was a very interesting movie out a few years ago with Joaquin Phoenix called Her, about just this, about basically an AI that is used for intimate relationships and what kind of things can happen with that. And it was very, very well done. It was very well done because I think what it did is a very good job of exploring the technical, practical, ethical, and emotional spaces that such a concept or construct in real world practice could entail and obtain. So I think that there is considerable risk there. Did I answer your question?
Yes.
Yeah, I mean, but I'll go further and to say, with every risk sort of assumes the face of Janus. The face of Janus is a two-sided demigod. One side was sort of light, the other side was dark. One side was benevolent, one side was not necessarily maleficent, but certainly. Okay. But I think that, some of the work that's been done utilizing forms of artificial intelligence as adaptive assistive technologies for individuals who may be bedridden, who may be shut in, who are aged, who may have lost a loved one, and who are going through what's sometimes referred to as geriatric grief, can be very, very useful. So this is some of the work, for example, of my colleague Herbert Plitschke at the Technical Institute of Applied Institute for Applied Sciences in Munich. It's not Technical University. It's at the Technisches Hochschule München in Munich. And Dr. Plitschke's work looks at adaptive assistive technologies, a range of them, inclusive of some of the work that he has done with a colleague of mine, his name is Nico Kohls and I, of adaptive assistive neurotechnologies. And one of the more far-reaching areas of these adaptive assistive neurotechnologies is exactly what we're talking about here. The creation of, if you will, a cognitive simulacrum that provides companionship. Then the question becomes, can you infuse it with certain characteristics, et cetera? So it goes back to the idea of the, quote, AI friend or the AI correlational. And as a consequence, yeah, there is something of a set of a fiduciary that needs to be established, whereby there are parameters that are well understood, natures of consent that are certainly informed and reciprocal. And I think those things are important. And I think some commercial forms of AI, quote, friends, are a little too cavalier in that approach. So, okay,
Thank you.
sure. Any other questions? Well, I hope I didn't bore you. I hope I scared you a little bit, but just enough to be sort of prompted on the edge, and that the facts that I told you and that the sort of realities that I've posed for you don't just answer questions, but prompt you to have ever deeper questions. And so I'll end with a quote in the spirit of the philosopher and historian of science, Bruno Latour, who said that science doesn't provide answers. It provides temporary answers whose goal is to stimulate ever deeper and far more reaching questions. So I hope that in that Latourian spirit, what I've done is provided you some answers, given you some insights, some information, maybe taught you some things, but maybe more than that, really stimulated your questioning, because questioning is good. And maybe that questioning will then deepen and broaden your own views of not only AI, but other forms of viable technologies that are engaged in the bioethical realm and what that means for us, for them, for individuals, and for society at large. So thank you very much for your time. Thank you for taking an interest in my work. And again, I wish you all the best. And feel free to get in touch with me if you have other questions. In the subject line, just put that you were part of this conference or this workshop, and I'll get back to you, I promise, as soon as I can. Thank you very much.
Thank you,
Professor
sir.
Lita, thank you very much for your gracious invitation.
Professor,
Yes.
this was fascinating by far.
Oh, thank you.
And thank you very much. And I would like to, yeah, we will talk about how we can develop, probably, I know you are very busy, how we can plan another talk, because
I'd like that very much.
You know what? Because I see participants are fascinated.
Oh, good.
And someone was sending a text saying, I like very much how this professor is talking.
Oh,
that's
very kind.
Yeah,
And I apologize for my horrible New York accent. So
there is no New York accent. but it's
anyway.
Interesting. We need one or two photos, if you don't mind, a group photo. Yeah, if you don't mind.
Sure.
All right, thank you so much. The photographers, so I need to play this role too, it's for...
Here we are.
A couple of them, please.
Perfect.
Formidable. And then now we would like to edit this video clip. And can we actually put it on our YouTube channel? Yes? All right. Thank you very much. Big honor.
Thank you. And again, thanks to all of you for your interest in my work. And